All right, so now we're live. All right, again, on the homework last night, I have the keys out, kind of set it aside. Let's take a look at this warm up. To me, this is the more important part. So, those of you who are at home, I want you to pause the video, do this warm up, and then come back because you doing it on your own and struggling and then coming back is where you'll learn. Okay? Okay, so everybody should be done now with this. I need to first, it says, using the data on the average temperature in a month and the heating bill at Claire's house that month, we want to make a scatter plot using the mean temperature as the independent. Remember, if the mean temperature is the independent, that's X, and then this would be Y. So we're going to put this in as list 1, this in as list 2. How do I even put the lists in? Where do I go? Cal, you got lucky, buddy. Peyton, what do I do?
You go to stat and then edit.
Okay, I go to, let me clear all this out. I'm going to go to stat and edit, number 1. Now, I already have the data from this list in from last period, but if you had other data in from another problem, how would I get that data out? You go up, press clear, and go down. And then over, and then up, clear down. And clear out your list, and then start fresh with 38, 42, 44, 36, and so on. Making sure that each of these numbers are paired with their partner. Okay? Are we good at entering our list in? Now, it says make a scatter plot. So, what'd you do? We're going to go to y equals, and we're going to clear out anything you have in there. Make sure your plot is turned on. So, notice up here, my plot 1 is highlighted. Make sure it's turned on. Now, what'd you do?
I went to the Zoom 9.
And you have to go Zoom 9. Now, guys, you can just press 9. Okay, 9 is stat. I oftentimes, when I'm teaching, go so that you have a visual of it, but you don't have to scroll down to 9. You can just press number 9 if you learn that Zoom stat is Zoom 9. That means it will fit our graph to these statistics instead of the last problem that we might have done from whenever. Okay? And then I'm going to hit 9, and there's my scatter plot. Now, part A just said make a scatter plot. You never have to graph the scatter plot from your graphing calculator to a piece of paper. I will never make you do that. Okay, are you guys good with A? All right, now, part B, I will make you write down. Part B asks you to find the correlation coefficient and the equation for the line of best fit. So let me pick on somebody different. Landry. So, Landry, how do I get my calculator to give me that information? Stat, calc, and number 4. Now, somebody in my 6th period class accidentally hit number 8. Number 8 is A plus BX. So, your numbers are flip-flopped. So, just be careful. You want number 4, stat calc 4. Okay, now those of you with the newer calculators, you've got to go down to calculate, hit enter. Mine is an older one, I just hit enter. Okay, I get this. So first things first, what is the correlation coefficient, Landry? Negative 0.86. So it's a fairly strong negative correlation. Fairly strong negative correlation. Does that make sense? As the temperature goes up, what happens to your heating bill? Goes down. Or as the temperature goes down, what happens to your heating bill in the winter? Goes up. Okay, so yeah, it's negative correlation, and our graph showed that negative slope. Okay, now, next thing is write the equation for the line of best fit. And they gave you y equals ax plus b, and they give you 8, and they give you b, rounded 2 decimal places. Landry, what'd you write down? Perfect. So here are the 2 answers that I would expect you to write down for part B. How'd you guys do? All right, part C, is this the part that's getting you guys tripped up the most? Part C says, okay, predict the heating bill For a month in which the average temperature was 40 degrees, is that X or Y? If temperature is 40, is that X or Y?
X.
X. So they're saying when X is 40, what is Y? Okay, when X is 40, what is Y? Aaron, how do I do that?
So you select the graph.
Okay, but I don't have the line there yet. So I have to get the line there. So I'm going to go to Y equals. And maybe that's why some of you had trouble. You cannot do this part until we graph the line. You can't graph the line unless you've ran the regression and have that on your home page. So do you have this on your home page? How do I paste this on my Y equals? Do you remember?
Y equals bars.
Bars, very good. Then what?
Statistics.
Statistics. Then what?
Equation.
Equation and regression equation. Now paste that whole thing there. Now guys, you already pressed Zoom 9. Now some of you do this all at one step. Then you'd have to go to Zoom 9, but I already did a Zoom 9. I've already seen this scatter plot, so I can just go to graph. Now, how do I do when X is 40? Do you remember, Aaron?
Second count.
Second calc.
And then value.
Value. And it's saying, what do you want me to let X be?
40.
40. And when X is 40, what is Y? So it tells you right here, when X is 40, Y is $81.73. Now, I'm going to add another one. Do you guys all still have this in your calculator? What about when X is 55? Try that one. Try that one. When X is 55. So everybody, what am I going to do? Second calc. Value. What happens when I type in 55? I get a what? Error. And this is where I had some people come see me today and say, what do I do again when they can't see my graph? Okay, so you go ahead and say, okay, quit. Go back to your window. The second button over. And notice that the X max is 50.3. And you're trying to tell your calculator, calculate it for 55. Your calculator's like, I can't do that. I don't have enough room. So what do you guys want to make your X max? 60, 56. Doesn't either one of those would be accept. 56 would work, 60 would work, whatever you want. Now, don't go back to Zoom 9. If you go back to Zoom 9, it's going to put it back to this window. Zoom 9 fits it back to that standard. And it says, hey, if you go back to Zoom 9, it's going to say, oh, my biggest X is 49. I'm just going to make it 50 point something. That's why it chose that value. Okay? So you've changed your window. Now just do a graph. And notice that your graph is stretched out a little bit. You have a little more space off to the right because we made that out to 60. All right. And now how do I do 55 again? I'm going to do what? Second calc. Value. 55. Enter. And how much would it cost when the temperature goes up to 55 degrees? $56.55. Questions? I was sleeping with the windows open last night. Anybody else sleeping with the windows open last night? It was a great night to sleep, right? And of course, I told you I live on a lake. This is my first year on the lake. I just moved in May. The flippin' geese were having an attack on each other at 4:30 in the morning. And they were flailing and causing all kinds of issues in the water. I was like, I just want to sleep. It was 4:30. I haven't been up since 4:30. I'm just so tired. I will go back to bed. Oh my goodness. Dang geese.
Do you have a boat?
Yeah.
Nice.
Like, so if you're asking us to find like a certain X, like they gave us 40, you just plug that in for X and 40.
Okay, you don't want to use the equation because the equation is rounded. Sometimes it gives you a rounded answer, and I won't accept that because you have a $100 calculator, and this is perfect. Okay, and great question. Anybody else? All right, do you guys feel a little better?
Yeah.
We're going to do another one to start class tomorrow. Another one to start class tomorrow. So every day we just keep starting with these problems. All right, blue sheets turned in. Please make sure they're all kind of staples in the upper left-hand corner when you guys collect those. Any better?
Those hands down.
There's so many other blue papers out because of your sheets. So. Okay. Do I have all the homework answer keys turned in? All right. So today we're going to talk about a system of equations with three variables. Three variables. Okay. So up until this point, you guys have had a system of equations with two variables that intersected right here at this point, x, y. X told us how much we went left and right. Y tells us how much we go up and down. A 2x2 system. Today we're going to talk about a 3x3 system. It looks like a lot. It looks like a ton of work. Do you know how to use elimination? You guys like elimination? This is just like 3 elimination problems all in one. That's why you only have 3 problems tonight. Okay, because anytime you guys come in and see that you only have 3 problems, you should be a little bit like, okay. So you have 2, 4, and 6 tonight. All right, and you get nice, neat, pretty answers. So now we're adding an element of z. So x still goes left and right. Y still goes up and down. Z comes in and out. In and out. Okay, so Z comes in and out. So now you're not going to just have X, Y, and Z. You're going to have 3 equations with 3 unknowns. And when you solve them, it will always be the point X, Y, Z. Now, I like to give you a visual. I will never make you graph these. Okay, I won't make you graph these. But if you have a system that has 1 equation, this is what it looks like. You have a plane, 3 planes that intersect. If they intersect right here at that point, again, that point is the point X, Y, Z. Okay? They might have infinitely many solutions. The planes might intersect all on this line. Notice I did not say all real numbers. Sometimes students say all real numbers, but this point out here is not a solution. Remember, when you had systems of equations, they intersected at one point. They intersected at no points, no solutions, or these guys were infinitely many solutions. You could not say all real numbers because all of the points along these coinciding lines are solutions, but this point right here is not a solution. It's just that this point is, and this one is, and this one is, and this one is, and this, and there's infinitely many that are on these 2 lines, but that one's not. Same thing here. It's infinitely many. Okay? Next one is if we have no solution, what's it look like? Well, they might not have any points in common. Yeah, the yellow and the pink have a line in common, and the yellow and the blue, and the pink and the blue, but they don't all 3 have in common with each other. You might have the pink in the blue and the yellow in the blue, but notice the yellow and the pink don't intersect. So that would be no solution. And you might have them all parallel to each other, in which case there are no solutions again. Is this anybody's in here? Not like shoes in there. I keep forgetting to ask that period. All right, so this is a visual for what it looks like. You don't really need to know that, but if somebody wanted to know what's this look like if I graph it, you will work with, if you become a mathematician or a physicist, you'll work more with 3x3 systems later in your career. For now, we're just going to solve them. We're going to solve them. And so here's what I want you to do. I want you to identify one of these as equation 1, one of them is equation 2, and one of them is equation 3. So we just identify them equation 1, 2, 3. I will tell you, the neater you are with this, the easier this will be. If you're sloppy, this will be difficult. Carter's just like, oh. All right. We are going to eliminate one of our variables, x or y or z. Which variable do you guys think I'm going to pick for this one?
Z, get it out of here.
Nope, not z.
Why?
Why do you think I'd pick y? Tell me why you think I'd pick y.
Me?
Yeah, you said z and I said no. They said y. So why do you think I like y?
Oh, because one of the Y's is by itself.
There you go. Cool. One of the y's is all by itself. So that's why we want to pick y. You want to pick the letter that has one of them all by themselves. Okay? So, I'm going to tell you, we need to do elimination, and we need to eliminate the y. All right, so Michaela, which equation do you want to work with first? Doesn't matter. You pick the one you want to work with first. 1. Okay, so I'm going to bring equation 1 down. 4x plus 2y plus 3z, write small. We got a lot of writing. All right, and now we're going to eliminate y. So do you want to work with 1 and 2, or do you want to work with 1 and 3? Yes, absolutely. Because 3, the y is all by itself, right? So that's hopefully why you picked that one. So she picked equation 1 with equation 3, and we said we're going to eliminate y. So just like we did when we did elimination back last beginning of the year, we need to make the opposites. What's the opposite of 2y? So what would you multiply this equation by, Michaela, to get them opposites? 2. All right, so I'm going to bring this one over. Being so careful not to change signs, lose negatives. That can just mess you all up. Okay, what do you get now when you multiply everything by 2 in this equation?
12x minus 2y plus 8y equals 6.
All right, did I create opposites, Michaela, and my y's?
Yeah.
Yep, okay, so we're going to go ahead and we're going to add those together. And when you do, what's 4x plus 12x? 16x. What happens to your y's? They're gone. What's 3z plus 8z?
11.
And what's 12 plus negative 6?
6.
Is everybody okay with what she did in her first part? I know you don't know why you did it yet, but are you okay with what you did? All right, now. She picked equation 1 with equation 3. Okay, so now, Carter, we have to use equation 2. You have to use You have to use each of the equations one time. So Michaela used 1 and 3. That means we don't have a choice, that we have to start out with equation 2. So she didn't leave you a lot of choice at the beginning.
Got it.
Okay? But she did leave you choice for your next equation, because now, okay, I've used all 3. Now you get to pick with equation 2, which one do you want to work with? Do you want to use 2 with 1 or 2 with 3? Keeping in mind, again, we want to eliminate y.
Well, I would probably want to do 2 and 3.
2 and 3. I would absolutely do 2 and 3. So once again, I'm going to write this down. Now, we want to eliminate y. What's the opposite of negative 3y?
The opposite of -3y.
Positive 3y. So what are you going to multiply that bottom equation by?
Negative
Hello, Sherry.
3. Bottom equation? Or negative?
Oh, no, Erin, it's time for you to go. Sorry, I wasn't. Yeah, she is. All right, bye. Sorry, I don't watch it. So when you guys have an early dismissal, you guys got to watch your time. I don't pay attention.
Wait, what?
She has an early dismissal.
Oh.
All right, and now what are we going to do? What did you say we were going to do?
We're going to multiply the entirety of 3 by -3.
By -3, right? Because we need this to become positive 3. So I'm going to bring this one over. 2x minus 3y plus 5z equals negative 7. Now, when you guys multiply that by negative 3, Carter, what do you get?
I get, give me a second. That would be negative 18
Uh-huh.
plus 3y
Uh-huh.
minus 12z
Uh-huh.
equals 9.
Guys, go back and double check just to make sure you don't mess up with your signs when you're doing your homework. Because if you mess up your signs, it just throws everything off. All right, I double checked as he was doing it. We're good. Now, add them together. What do you get here?
You get negative 16x plus the negative 7z
So I'm going to put minus 7z.
Equals 2.
So, is everybody okay with how I got the green equation? Now, do you see what we just did? I eliminated y and have now created a 2 by 2 system. 16x plus 11z equals 6, and negative 16x minus 7z equals 2. At this point, you can use substitution or elimination. Is this already set up for elimination?
Yeah.
Yeah, Grady, are we already set up? Do we already have opposites?
Mm-hmm.
Yep, so just add them together. When you add them together, what do you get? 4z equals 4. Z equals 1. So he's got one of his 3 letters, way more than a third of the way done with the work. We got one of the letters. Now, Grady, we got to find x. So which of these do you want to plug it into? The red one or the green one? It does not matter.
Z equals 1, right?
No.
Yes, Z equals 1. Thank you. So which one do you want to plug it back into?
3.
Nope, you don't. You can't plug it back up there because you don't have x and y yet. We're going to plug it back into one of these.
Oh, sorry.
What's going on? What am I doing wrong? Everybody's
8.
hang on. Glad y'all are yelling at me. That's 8. All right, stop. Woo! Back up, Mrs. Emerald. I'm thinking about Erin and how I made her late for her appointment, but I feel bad. Okay, sorry, Erin. Hope you made it on time. Okay, back it up. Back it up. All right, ready, Grady? Now when we add, the 16s do what? Cancel. This gave me,
4.
and this gave me. No, it doesn't. What is 6 plus 2? All right, you talked me into that. Now what?
Now 11, 4. And Z.
Okay, now we got lots of hands. Thank you for waving at me, guys. All right, now what, Grady? Now we're going to plug 2, and do you want to put it into the red equation or the green equation? It doesn't matter. Red. So we're going to do 16 plus 11 times 2. 16x. This is Naples having an afternoon equals 6. All right. What are you going to do now, Grady?
11 times 2 is 22.
Okay, perfect. Now what?
Minus 22.
And we get what? There we go.
8. 16. 1 divided by
And you get x is what?
negative
-1.
1.
Okay. Sorry about my speed bumps there. All right, now we're going to go all the way back to the top, Cole. We have x, we have z, we just need y. You get to pick equation 1, equation 2, or equation 3. Which one do you want to work with? The first one, okay? So Cole wants to go into the first one. So Cole, you want to do 4x, so 4 times -1, plus 2y, we don't know why, plus 3z equals 12. All right, what's 4 times -1?
-4.
What's 3 times 2?
6.
Combine your like terms over here. What do you get?
+2.
What are you going to do now?
2y equals 10.
subtract 2. 2y equals 10. Keep going.
And divide by 2, so y equals 5.
Y equals 5. So we've got x, we've got y, we've got z. You will always write it as the point x, y, z. So we're going to write it as -1, 5, 2. Thoughts?
That's not bad for the.
Hey, it's a lot of work. There's a lot of places for silly little mistakes, obviously. So be careful. You will get nice, neat, pretty numbers on some of the problems. Some of them are no solution and infinitely many, which I'll show you in a minute. Well, maybe 5 minutes. Let's look at example 2. Start by identifying equation 1, equation 2, equation 3. I just really think that helps. Okay? And now, who's my person that gets to help me? Erica. Okay, first of all, do you guys want to eliminate X, Y, or Z? X, right? Because look at 2 and 3. All right, you're my first person, so you get to pick which 2 you want to work with. Huh? 2 and 3. Yeah, I would work with 2 and 3. Because, guys, are they already opposites? Yeah, if we're eliminating X, are these guys already opposites? Yep. So go ahead, Erica. Add those together. And what do you get? Negative y plus z, -3. Perfect. Okay. Dalton, she used 1 and 3. So which ones do you want to use?
1 and 2.
1 and 2?
Yeah.
Okay. If you use 1 and 2, what are you going to multiply 2 by?
Define y.
We're getting rid of x. You got to get rid of the same variable.
4.
Be careful, that would make it opposite. -4. Okay, we're going to multiply by -4. So I'm going to bring this one over. 4x plus 5y minus 3z equals 15. What do you get when you multiply this one by 4?
-4x.
-4x. Hang on, I drug my hand all over that. Okay. -4x
Plus 12y minus 8z equals 24.
Being a middle school has definitely added a whole nother element of crazy.
I cannot focus.
It's okay. It's okay. What happens here? They cancel. What do you get here?
17y.
Okay. What do you get here?
-11x.
Z. Okay. And what do you get here?
39.
Okay. So now I need to put that one with this one. I need to put these two together. Do you guys see what I'm doing? All right. If I make the y's opposite, what would I turn them into? If you guys made them, you would turn them into what? The y's opposites. You'd turn them into 17. If I made the z's opposite, what would you turn them into? 11. Gavin, what do you want to do? Do you want to make them 17s or 11s? So we're going to multiply this equation by what? 11. So when you do, what do you get? Adam.
So Gab, you got it.
Dude, calculator, you're breaking my heart.
Calculator and a pen, like Six Y, and then those cancel out, and then 6. That also be 6.
It is?
So why would you do
Okay. Y would equal 1. All right. Which one do you want to go back into then to find Z, Ethan?
Top one.
Top one. So -1 times 1 plus Z equals -3. What's -1 times 1? Most of you will just start at that step, and that's fine. What are you going to do now, Ethan?
Add 1.
Add 1 to both sides, and when you do, what do you get for Z?
-2.
All right. And then how do I find the last one? Your call, Skylar. Which equation, 1, 2, or 3, do you want to use for X?
The first equation.
The first equation. So 4x plus 5 times y minus 3 times z equals 15. I know most of you probably wouldn't have picked her equation, but that's okay. Skylar, what's 5 times 1?
5.
And what's this give me?
6.
Positive 6. Okay, what do you get when you put those together?
4x plus 11 is 15.
Okay, what are you going to do now?
Subtract 11.
What do you get?
4x equals 4.
Okay, x equals 1. So my solution as a coordinate point is x is 1, y is 1, z is -2. Now, I know we only have a few minutes, but I'm going to show you something really cool in example 3. Okay? That's the only one we're going to do. We're going to get started. We will be done in 2 minutes. Watch. I'm going to say I want to work with equation 1 and 2. I want to work with equation 1 and 2. And I want to eliminate x. What would I have to do to eliminate x? I would multiply this by what? -5. Okay, let's do that. When you guys multiply by -5, what do you get? Everybody. -5x minus 5y minus 5z equals, bring equation 2 over. You should get some, What happens when I add these? What happens to the x's? They cancel. What happens to the y's? What happens to the z's? Special case. So what's left over here? 0. What's left over here? Does 0 equal -7? No. If you get a false statement, 0 equals -5, 0 equals 3, you're going to tell me there's what? What if you get 0 equals 0? Is that true? So you're going to tell me infinitely many solutions. Thoughts? Okay, one of them is a special case tonight. 2 of them work out to nice, neat, pretty numbers. All right. Oh, you got 30 seconds. Goodness gracious, children.